first three things we're going to talk about is reflexive, symmetric, and transitive. And if you are really good at alphabetizing things, you see that these are in alphabetical order, which is how I remember them. The reflexive property makes me think of a reflection in a mirror. And the rule is the stupidest rule in mathematics. It says A equals A. Everybody's equal to himself. You're comparing one thing to itself.
Can we take notes on this?
It's kind of here. These are your notes. Just make sure you understand them. When we go to symmetric, it's the second guy in the alphabetical order. We're comparing how many things? Two things to each other. Symmetric says if A equals B, then B equals A. So you see how to remember that reflexive is one thing, symmetric is two things. Well, what do you think transitive is?
Three things.
Three things. T for three, okay? So transitive has to be in this order. If A equals B and B equals C, then A equals C. So first, second, third, first, third. It has to be in that order. If you want to write that down on your cheat sheet, you're going to be able to use this cheat sheet to do your proofs, okay? Remember, it's like that. If it's not like that, it's probably substitution. So now we've got subtraction, addition, multiplication, division. I'm going to talk about all of those at the same time. When we are doing algebraic proofs and we add something to both sides, or subtract something from both sides, or multiply something to both sides, or divide something on both sides, that's when we use those four proofs, okay? And I'm going to show you what I mean in a minute. So only in the line where you're adding something to both sides. And we've got to show our work on this. And we're going to do a couple proofs together, all right? So remember that the addition, subtraction, multiplication, division is that. Substitution is when you clean it up after you add something to both sides or subtract something from both sides. And I'm going to explain this really easily in a second. Divide or multiply something from both sides, okay? So that's when you use substitution. And distributive property is only used when you are foiling in a number and you're eliminating a parenthesis. So if you want to write next to distributive, you're taking out a parenthesis. That's what that is. Substitution, next to that, put clean up. When you're cleaning it up, you use the word substitution, okay? This is your first example of a proof. We're going to be doing proofs for the side, angle, side, angle, side, and angle, side, angle after we get this kind of mastered, which will be next week sometime. So I need you to know that when you have a proof, you have something that's given. Given is not gossip. It's something that's in the problem. Do you see where the given is in this problem? It's at 4x plus 6 over 2 equals 9, okay? Yeah. That given is always going to be, whatever you're given is always going to be the first part of your proof. Because you got to start with what you're given and then go from there and prove it, okay? This is a simple algebra question where you have to leave the x alone, which you've done before. So there are different orders to this, but they want you to use the order that they're using. So the first step of a proof is always the given. So that's 4x plus 6 over 2 equals 9. And the reason of a given is always given. So that A reason on that first one at the bottom of your page is given. Do you understand why it's given? Because that's what they told you, right? So anything that's given goes first. If they give you three things, you're welcome to put all three as 1, 2, and 3, and then kind of deal with each one individually, okay? So the second one, they left a little blank on B, right? What are we multiplying both sides by as our first step? 2. You see the 2 you have to get rid of?
Oh, yeah, that's right.
So it's 2 times 4x plus 6 over 2 equals 2 times the 9. We've multiplied both sides by 2. And when we use multiplication property is when we multiply both sides by something. That's when we use it. We cleaned it up. We went ahead and canceled the 2 2's on the left, and we multiplied 2 times 9 on the right, right? When you're cleaning it up, it's called substitution. Does anybody not understand that? So on 3, since we got rid of the 2 2's and we combined 2 times 9 is 18, that is cleaning it up, so that's substitution. Anytime you just make it more simple by doing some of the math and the one before it, you're substituting, okay? So number 4 says 4x plus 6 minus 6 equals 18 minus 6. Yeah, what are we doing to both sides of the equation on that one? We're subtracting 6. That's what we added to get from here to here. So this is subtraction. And subtraction, it looks a lot like substitution, but they have different letters. Yes. 4x equals 12. What did we do there to get from here to here? Cleaned it up. So what is that reason? On these proofs, they're showing every single step, okay? So the next one says 4x over 4 equals blank, and the reason is division. So when you divide one side of an equation, what do you have to do to the other side? You have to divide both sides. So you do both sides by 4 if it's going to be division property, okay? And now the 7th thing is we're going to clean that up. What does the left side clean up as? X equals 3, and that's substitution. Because we cleaned it up. And look at here, we're proving that x equals 3. We got that as our last reason. Your last statement is always what you're trying to prove. You don't stop until you get to that statement, okay? So we said, given this, prove this. First guy is the given, last guy is what we're trying to prove, okay? The reason for what you're trying to prove is never prove. Don't ever use that as a reason. That's just what they're telling us to prove. You've got to put a real reason in there. Never, ever, ever use prove as a reason. So here we go. The first reason is always given, and you always put the given that's up here, okay? The second one says 4x plus 8 minus x equals x plus 2. What do we have to do on the right side?
Would that be addition and subtraction?
No. What did we change to get from 1 to 2? We did the minus x. So we're going to just put subtraction on here.
Oh. Yeah, because I was looking for which one said subtraction.
Well, they have them grouped together, the multiplication and division,
Yeah.
but I want you to put what it is. So it's subtraction. Okay? We're subtracting both sides of that equation by x. All right? Now, can we clean that up on the left? How does that clean up to?
3x plus 8 equals 2.
And that's substitution. Very good, because we're cleaning it up. I think you guys are getting that part, right?
Yeah.
When we go to step 4, and I am isolating the variable, what would I have to do to leave this x alone? What would be the next step?
Subtract 8.
We subtract 8, so it would be 3x plus 8 minus 8. You have to write it out. Equals 2 minus 8. And what would the reason be?
The subtraction property.
Very good. Subtraction property. So now we clean up again, right? There's a lot of cleanup in these. And that gives us 3x equals negative 6. And that's substitution. To leave the x alone, we have to divide both sides by 3. And that's division, because we're dividing both sides by 3. See how you have to add?
And then you have to do substitution again to find it.
X equals -2, and the reason is substitution.